is looking at synchronous versus asynchronous programming. For the most part, what we've been doing so far is like in synchronous fashion. But in order for us to be able to talk to our API, we need to understand at least the basics of asynchronous programming and what that entails. So in order to help us do that, I've got a scenario I want us to take us through.
So guys, sometimes you might hear the term sequential programming. So sequential programming and synchronous programming is the same thing.
Yeah. I'll talk a bit about that as well as we go on. In this scenario, we've got a restaurant. So in here, we've got a customer, we've got a waiter. Let's say the waiter is Jason and the customer is Andre. So Andre puts in an order for 4 hamburgers. Jason wants confirmation of that. Andre insists. Jason heads off to the kitchen and puts in the order. And then Jason decides to wait while the order is being prepared. At some point later on, the order is complete. And then Jason fulfills the order by bringing it to Andre. Andre is over the moon. Andre takes his order, he exits, and then the next customer steps up front and the process repeats itself. So of course, this is a bit of an inconvenience for the very last person, which is myself, because in order for me to put in my order, I need to wait for all the customers in front of me to have their orders fulfilled. Because essentially what is happening is when Jason puts in the order, Jason waits till the order is fulfilled and then delivers it to the customer. So this sort of process is described as synchronous. So as Jason alluded to, it's a very sequential way of doing things. The execution of this task, i.e. fulfilling the person's order, happens in a single series. So Jason fulfills Andre's order completely. Then the next customer comes and the process repeats itself. So depending on how long the order will take, you could potentially be waiting for a very long time. Could be very expensive in terms of time. We see this in the real world. For instance, with McDonald's drive-through, that's an example of a process you would describe as synchronous, because all these cars are lined up. The car at the very front puts in their order. All the cars behind have to wait until that order is fully prepared, fully fulfilled. And then that car goes on, and then the next car comes up. So if you're the car at the right of this image, you're going to be waiting for at least 5, 6 cars ahead of you before you go. So to give it a description, when we say synchronous, we essentially mean that your program is going line by line, performing each task one at a time before moving on to the next one, which means that for the last task or command in the code to run, all the code prior has to be executed, but not only executed, it needs to be resolved first before it gets to the last task or command. So in some situations, synchronous is not so bad. For instance, if we need to load in configuration in order to start up an app, it makes sense for that to be, perhaps done in synchronous fashion, because without that configuration, the app is not going to run. The app is pretty much useless, for instance. And this also guarantees that your data is in sync if things are done in synchronous fashion, because it shows that there is some kind of a dependency chain going on. And I'll expand on that a bit as we move on. And this brings us to the asynchronous style when it comes to programming and to describe. Hello?
So I just said asynchronous processing. Yeah.
Okay. So to describe that, I'll present another scenario. So go back to the first, I'll resume from the first scenario from when Andre puts in his order. Jason goes ahead and puts the order in, but rather than Jason waiting for the order to be fulfilled, Jason goes ahead and serves the next customer. Andre, in this scenario, is given an order number and asked to wait for that order. At some point in time, the order is completed. Andre is notified. Another waiter delivers the order to Andre. Andre is over the moon. Andre heads off into the sunset. At this point, we see that some customers that have already been served by Jason. So what we have effectively are two different processes, two parallel streams of work. Jason putting in the order and then the other waiter fulfilling that order. This is described as asynchronous because this is happening in a non-sequential fashion. We've got parallel, we've got the execution of Andre's order being fulfilled happening in parallel, right? And this approach is quite good if the tasks you're performing are can be described as independent. So if I need to make an API call, it makes sense to do that in asynchronous fashion. That way the UI is not blocked, because when we're performing tasks in synchronous fashion, the UI gets blocked. So imagine if you're uploading a video via WhatsApp to someone. To have that done in synchronous fashion, that would mean WhatsApp would freeze while the video is being uploaded. But then because it happens in asynchronous fashion, when you upload the video via WhatsApp, you find that you're able to perform other tasks while the video is being uploaded. So that is essentially asynchronous. If you care about data synchronization, then sometimes doing things asynchronously could have your data being out of sync. So an example with that is, for instance, Dropbox. I've got Dropbox on my Mac and my Windows. When I'm doing my recordings, I save it on my Mac, so it syncs across. But then sometimes I've got an earlier version of Windows, which also syncs across when I open it. So what I find is that my latest recording gets overwritten by the synchronization that happens from the Windows side of things. Which is because with the nature of the synchronous processing or programming, what you want to call it, things happen in a non-sequential manner. They happen quite independently. A real-world example of this working pretty well is with Argos. When we go to Argos and we put in our order, we don't need to, the person serving us does not wait for that order to be fulfilled. Rather, we just get an order number and we're asked to wait. And at some point on this display, our order gets called out. So with this image, you can see that this happens in asynchronous fashion, because even though order number 713 went before 714, 714 is ready. Meanwhile, 713 is not yet, because, depending on the size of the order and what is being ordered. So we can describe asynchronous programming as a means of parallel programming in which a unit of work runs separately from the main application thread. So that's the main application program, and notifies the calling thread of its completion, failure, or progress. So in this case, the calling thread could be the customer, who gets notified at some point in time that, your order is ready, or your order fails for some reason, or get a progress report. with its order depending on, you know, how long it's taking. In Dart, we are able to do asynchronous programming, and one of the main ways of doing that is futures. There are also several other ways, such as streams and microtasks and so on and so forth, but we're not going to be covering that. What a future essentially is it represents an operation that produces and returns a value at a later time. So whenever we create a future, the operation gets sent to the background, and then at some point, a value gets sent back to our main program and we can do something with it. So we've got an example here of a future. This future produces the value got data. At some point in time, we'll get the string got data. From here on, we can be tempted to assign this to a variable and then attempt to print it out straight away. But when you attempt to do that, what you see is you just get a piece of text that says instance of future, and in this case, the type is string. And the reason why that happens is because, like I said, this happens asynchronously. So that means we need to do something else in order to get the actual value back. In fact, this is equivalent to having your order number or your ticket number. So to get the actual value back, we need to define a couple of methods that are exposed by the future object. So one of them is called .then. With this one, we define a function that contains the result of the future. So we're saying whenever the future returns a result, whether it's 5 minutes or 50 years, we can just print it out. We can do something with it. So in this example, we just print out the result to the screen. If at some point in time the future failed, we can do .catch error, and that would allow us to catch our error message and then print that out to the screen. And then lastly, we can define a method called whenComplete. So this allows us to define an operation that would run irrespective of whether the future was successful or not. So just briefly, I'm gonna show a code sample of that in action. So I've got my DartPad here. You don't need to type this out yourself. I'll send you the link afterwards. But we've got a future operation happening. So if I run this, printing data gives me instance of future string. Like I said, that's like the order number. And then at some point it's successful. So we just print it out, which gives us this one. So let's say for some reason, the future failed. And then if I run this, and while that's running, you notice the whenComplete runs irrespective of whether it succeeded or failed. So in this scenario, our future failed. And as a result of that, this section was invoked. We got the error message, and we're just printing that out to the screen. And then afterwards, whenComplete block also runs. Okay. So I'm gonna come back to the slides. And at this point, it might be a bit confusing. Maybe the way futures work, trying to keep track of then and catch error and whenComplete. So we've got a language feature that makes this much more simpler, called a sync await. And what a sync await does is allows us to declaratively create a future object and also pause and also wait for a response from there. So rather than us doing something like this, we can do this instead. So what that involves is you mark the function that your future is happening in with the async keyword, and then on the line where we are expecting a future, we'll use the await keyword. So in this example, when we print out data, we get the actual response, because the minute your program hits the line with the await, it'll wait for the future to resolve with a success or an error. And in this case, we just print out data. So this covers the success case. In the scenario where you need to listen out for an error, you need to wrap it in a try-catch block. So the try will be the attempt to run the feature and resolve it. If there's an error at some point, we will just print out, we can catch the error, and then we can, with this example, we'll just print it, we're just printing it out. And the equivalent of when complete is that we've got the finally block here. So whether it passed or not, this finally block will also run. So I've got a quick code example from that. And we've got that here. So if I go ahead and I run this, we got data, and then done. And then if for some reason it failed, we get got error, and then we just log out, we print out done. All right. Do you have any questions surrounding this at all? Anyone? No? Okay. So let's go back to the slides. And then at this point, I'm gonna just talk briefly about our public API that we're gonna be interacting with. And this is the ITV programs API. So this API will give us a JSON object containing details of all the programs that have been streamed on ITV. So that's the JSON response. We need to make a request to that API, and the instructions are as follows. We need to make a call to this URL, but also while making that call, in fact, let me open this in the browser and show what we get. So clicking that URL brings us to this page. This is what the JSON response looks like for each program. So each program has got an ID, has got a title. If we open this up a bit more, we are able to get details about our duration. And then under links, image, we get a link to our image thumbnail. So all the details we need are in this API response. Okay.
And guys, what's interesting is that a lot of content providers, like the BBC, Netflix, and so forth, they will all have public APIs that allow developers to connect to. So this just happens, we happen to be using the ITV one, but you could go to Netflix and you could look at their one. You could go to BBC and look at their one, and so forth. Okay.
Cool. And also, if you notice, this opened up a HTML page, but we do not want the HTML page. We want the JSON response. So in our request header, we also need to send in this value. So request headers essentially allow us to add additional information to our API calls that we're making. So this just tells ITV that we expect a JSON response back, or else if we just do a request to this one in our code, we just get a HTML file, which is what we do not want. So at this point, I'll just take us back to the code. Okay. So in order to make our API calls, we need to install a package called HTTP. I'll go ahead and share the gist link in the chat. So you should have that. And we need to install a package that will allow us to make our HTTP calls. So this package is called HTTP. And we want version 0.12.2, not 12.2. So I'll save this. And in order to update our packages, we can run Flutter pub-get. Because I'm using VS Code and the Dart Flutter extensions is done already, but I mean, we can go ahead and do it again. No harm in that. Okay, so now that's done.
Jermaine,
yeah.
is there not a way to get the package without having to update the pubspec.yaml? So effectively a bit like what we do in the React Native space where you call like yarn add and then you've got the package name. Is there an equivalent like that in Flutter?
There isn't an official one, but I remember coming across a package called PubAssist, an extension called PubAssist. I had it installed on my previous Mac. For some reason, I forgot to install it here. But what that would do is you pull it up as a command, and then you type the package you're looking for, and you'll go ahead and add it in here. I'm not sure if you'll go ahead and run pub-get, but I assume it does as well. Okay, so let me just close that. And then at the top of my file, I'll go ahead and then import the HTTP package. So we'll start with a package prefix, and we want HTTP, then HTTP dot. And this gives us access to a function called get. So I will come down here to my state class. And what we need to do here is when the app first loads, we will essentially go ahead and make the HTTP call straight away in order to get the results to display. And so I will go ahead and create a state property called programs, because we'll get the results and then we'll do a state update, and we'll assign the results to programs. And then secondly, I'll go ahead and define the method that'll make the actual API call. So this method returns a future. And then the type of future is list. And then the name of the method is get programs. And then I can go ahead and in fact mark this with the async keyword. So we're going to use async await. I'll show what it looks like without it, and then I'll introduce async await. So then over here, we'll just go ahead and invoke the get method. So this comes from the HTTP package we just imported in. And then for our URL, we'll go ahead and paste the ITV URL. So that should be in the code that I sent you guys. So this is this whole URL. So let me save that. Okay. You also need to go ahead and specify, like I said, we need to pass in the request headers to that. So we can set a headers name argument, and this takes in a map of headers. The one we need to specify is the accept header, and then the value of that would be this piece of string over here. So this is just our ITV that we want JSON data back. And from here we can do .then. For now, we'll just print out the response body, if we can. Let's print out, oops. Let's print out response. Next step, we need to invoke this get programs function. So in order to do that, we can override, we need to override an inbuilt method that state objects have, which is one of the several lifecycle methods. So if I say lifecycle methods, these are methods that run from the time these widgets are created to when these widgets are destroyed, essentially. So the lifecycle method we need to override is called initState. And then what we need to do in here is to first invoke the initState from this parent class. So when this runs, it will run the initialization that Flutter does behind the scenes before we go ahead and run our actual code. So at this point, we can do get programs as such, and it'll go ahead and it will do our API call. So let's just test this out actually. So I'm going to restart, do a hot restart, and let's see what that gives us. Okay, so we get a response back. We actually want the body of the response. So let me do a hot restart again. Okay, so our response body gives us this JSON response. And just to give you an idea of what this JSON looks like, I'll create a JSON file here, and then I copied this earlier on. But essentially, this is what the JSON response looks like. So it's an object, it's got the embedded key, and in there it's got our list of programs. So from here, I will modify this a bit by using the async await approach, but the then block would essentially look something like that. But then I'll use async await because it's much easier to read. And I'm going to scroll back up firstly, and then I'm going to alias this as HTTP, so that over here I can do http.get. And this is useful because, you know, if you've got multiple imports, you can give it an alias for a particular import, so at least you know where these functions come from. And then I'll go ahead and create a response variable. And then here we want to await on this request. In fact, I can make that HTTPS as well. I'll get rid of this then block. And from the response that comes back, we can, before we use this response, we need to decode it because it comes back as a string. So I'll create another variable called decoded response. And what this decoding does is it will transform that string into a Dart object. So that means we're able to dive in and access the actual list of programs we want. In order to decode, we need a decoder under the JSON object. So I'll come up here and I need to import an inbuilt Dart library called Dart convert, which means that I'm able to now do JSON.decode. In here, we need to specify a source, and to actually access the JSON string in our response, we'll do response.body. And then from there, we just need to return our decoded response. Since that gives us a Dart object, we don't want the whole JSON object, we just want the list of programs. So we need to traverse the embedded key and then the programs key to give us this list. So if we do decoded response, and then in here we do embedded, and then afterwards we'll do programs. Such. So once that is returned, so at this point, we've returned the response from our Ajax call, which is this list of programs, which means that in our init state methods, when we do the call to get programs, we can go ahead and do .then. We can capture our results. And then we'll invoke setState and then assign results as a value for our programs. Okay. You can test that, but at this point, we're not going to see anything on the screen. So let's go ahead quickly and display the list of programs in our list view. But before we do that, because we're using this list view, because this list view assumes that we have a list of results, and we don't yet, so I'll make this list view. We're going to make this list view conditional. So if you've got results, then we'll show it. If not, then we'll render something else. So I'll check if our programs list is null. That means we've not got anything yet. I'll go ahead and we'll render a text widget that says loading programs. If we've got a result, then we'll show this list view. So I'll save that. Okay. And then to And to display our list of programs, I will delete this bit for the list view, and then we'll take our programs. So at this point, we're confident that our programs gives us a list. And what we'll do is we'll map over our programs, and then we'll put the data in a widget, because this list view children expects a list of widgets. So in here, map, this gives us our program. I'll delete that bit. And then we can return the list tile widget for each of our responses. So this list tile, where list tile is essentially it actually comes part, it's used to render items in a list view. So a list title has got various parts. So there is a title that we can define, which takes in a text widget. And from here, we can render our title. So if we go back to our programs, each program, we just want the title key. So we can just do program title. You can also define a subtitle. And then in here, we'll grab the program synopsis. So this bit, synopsis, and then 90. Search, and then we'll do 90. And lastly, what we need to do is to convert this map result into a list. And to check, and I'm going to go ahead and do a hot restart as well. Okay, so it looks like we're getting an issue here. Let's see what we have. So try calling 90. Let's see. So I think it's synopsis 90. Synopses. Sorry, wrong spelling. I'll do another hot restart. Okay. Okay, so hot restart, and yeah, there we go. You get this list of results. Because we're using the HTTP package, if you're running this on DartPad, you notice that it won't work. But then in the code, in the gist that I sent you guys, are instructions at the bottom on how to get it working for DartPad. Let me try and pull that up for you guys. So if you go to DartPad, rather than doing this line, you need to import the Dart HTML library, because we're running it for the web. And then if we go all the way down to where we make our API call, we just need to do HTTP request dot request. Next, we need to specify the method of the request. So it's a get method. And over here, rather than headers, we need to set request headers. And then lastly, instead of request.body, we need to do request.response text for that. And then lastly, we got this error here to do a void callback. And that's because this void callback reference is being imported from two different places, the Dart.html library and the Dart.ui library. But to solve that, we can just come over here and then do hide. And then I'll hide void callback. So the error will disappear. That means we're using void callback from the Flutter library. So if I go ahead and run this, it will go ahead and load the programs and we can see the results over here. I'll also send you guys this link in the chat. Yeah, so you could go and check that out yourself. All right.
Jermaine, can I just ask you a quick question with regards to installing that dependency, the HTTP?
Yeah.
I've got a few errors actually when I was doing that. So made a change to the pubspec.yaml, yeah. And then what's the next command to actually install the dependency?
You need to run flutter pub-get.
Ah, okay. Flutter.
Yeah.
Okay.
Okay.
No, still get an error. Yeah.
Okay, so we're running a bit behind time, so can speed up to the next bit and I can take some questions at the end.
Sure.
I got a question here. Why do you need to convert a list view to list from Damien? So we're not converting the list view to a list. We are converting our programs that we've mapped over. So what map does is it will take each of the objects in our programs, and then we are rendering a list view and passing the data in there. The reason why we need to call toList because map doesn't return a list object. So if we hover over that, it returns an iterable. So from there, we need to convert it to a list because the list view children expects a list of type widget. Okay, let me come back now. So in the next, also another way of handling this bit, rather than writing logic like this and then doing .then and .catch error, the Flutter team have put together a specialist widget that simplifies this for us. So this widget is called a future builder. So if I send you the code for that, and if you look at that logic, the code I sent to the chat, you should be able to see an example for that. And I'm going to go ahead and show what that looks like. So rather than having this bit, I can just comment this bit out for now, and then we'll specify a child for the center. This takes in a future builder. So future builder will take in our future code that we're making, and then the builder allows us to capture the results of that future and render our widget to the screen. So from here, I can say the future is going to be our get programs. And then here we'll specify a builder property, which is a function that gives us the context and a snapshot. So this snapshot contains details about this operation, which means that in this snapshot we can, for instance, listen for various pieces of information. We can listen for, we can check the data property, or we can check first that it's got data, we can check it's got error, and we can check other things about it. So in this example, we want to check that it's got data, which means that our future was successful. And then at that point, we can return this list view. And I'll just re-enable that. Okay. Also, we need to check for errors. So if at some point there was an error, can do has error, then we'll return a text widget, and we can also grab the error from the snapshot by doing snapshot.error. And then anything else, so if there is no data, if there is no error, then we could assume that it's loading our programs. So I can just copy this and then return loading programs, such. So doing this means that we can delete this bit, and also we can go ahead and in fact get rid of that init state section. And also we can delete our programs, I think. Oh, no, yes, we can. Because in order to get the data, we need to do snapshot.data. So that gives us the data from our future operation. So let me save this, and then let me restart the app. Okay, so that gives us an error. And that's because this list needs to be cast into a widget, because this list view expects a list of widgets. At the moment, it's set to dynamic. So to do that, after map, we'll just set the type of it as such. So the results will be cast to this type called widget. So let me save that, and that will give us these results here. Okay. Does anyone have any questions about this bit? Okay, I guess not. So the next step is to bring in this program card, because at the moment, this is not what we're looking for. So to do that, I can get rid of this list style, and instead we'll render our program card. This will still take in our isFavorite property, and then our Untapped event. So for now, I'll just invoke our update favorite function over here, method. So if I go ahead and save this, that should now give us this list here. You can also click to update our favorites next, what we need to do is to pass in the actual program data and then use that to dynamically set these bits. So what I'm going to do is, in fact, I'll send you the code for that as well. Oh, hold on, I think I already did. Yeah.
Yeah.
Okay, cool. So for this program card, I am going to define another property here, a named parameter called program. And this is a map of key value pairs. Then we set program here. So let's go ahead and also pass the program here. So at this point, we're now able to unpack this program and extract the details we want. So let's start with this image, this network image. If you look at the JSON response, in order to get that network image for each program, we essentially need to come down to embedded and then go into our latest production. And then if we go all the way down, we go into our links and then our image and our href. So it's, yeah, it's a bit of traversing, but not an issue. We can do program. And then in here, we want the embedded key. We want the latest production. In fact, I can copy that. And then we want links. And then image. And then the href. So let's save that and see what that gives us. Okay, so now we're getting the images pulled in. Let's go ahead and sort out the program title. And for that, I think that's the easiest bit. You can just do program.title. Then we can access the title key. So save that. That's set the title for us. And lastly, we need to get the duration. So if we go back to the JSON object, that's under embedded latest productions, then duration, and then display. So we'll do program, embedded, latest production, and then duration. Okay. And we want the display. Okay, so that should now give us the updated minutes for each of these. All right.